We are on Learning Target 15, Day 1. Learning Target 15 is all about rate of change. So we need to know what a rate of change is. And it's a ratio of two changing values, hence rate of change. So a rate of change that you are very familiar with is miles per hour. First thing we're going to do is look at how to find rate of change from a table. So our essential question today is, how do I interpret rate of change? Rate of change typically has labels that tell us what it is that's changing in respect to one another. So the first thing we want to do is determine if the rate of change is constant. If the rate of change is constant, it is linear, and that's what this entire unit is about, is linear functions. If the rate of change is not constant, it is not linear, but we can still interpret what it means. So our first example, we're taking a look at a hockey team's offense throughout the course of 3 games. So in game 1, they had 2 goals. In game 2, they had a total of 4 goals after 2 games, and after 3 games, they had a total of 6 goals. So to find if the rate of change is constant, we find the change in y and the change in x. Anytime you are given a table, x is the first column and y is the second column. So you never have to think about, well, which one's x, which one's y. It's always given to you in that order. So the reason I wrote change in y first instead of change in x first is because of what we're going to do next once we find these values. So change in y, this is like what we did with our sequences. We've got this list of numbers 2, 4, 6. What are we doing to the 2 to get a 4? Well, we're adding 2. What are we doing to the 4 to get a 6? We're adding 2 again. So over in my x column, we've got another sequence, 1, 2, 3. What are we doing to the 1 to get a 2? Plus 1, 2 to 3, plus 1 again. Once we have those values, we are going to set up a ratio. So looking at my first ratio, let me try and clarify this, I'm looking this way. And it's change in y over change in x. So my first ratio is 2 over 1. The triangle means change in. Then I'm going to look at my next ratio, and change in y over change in x is again 2 over 1. Once I have those ratios, obviously 2 over 1 equals 2 over 1, so this is a linear relationship. And then we need to use labels in order to interpret what this rate of change means. So first of all, let me answer the question. Yes, it is linear or constant rate of change. And then secondly, if I label my change in y and change in x, my change in y was change in goals, and my x was change in games. So if we simplify this, this 2 over 1 means that we scored 2 goals per game. So that is the interpretation of our rate of change. Let's take a look at another example and practice this some more. The labeling the rate of change is what I found to be the most difficult part for students typically. So same process, find the change in y and the change in x. Remember, x is always your first column, y is always your second column. So looking here, 80 minus 25 is 55. Here, 140 minus 80 is 60. And 190 minus 40 is 50. Looking at our gallons, we had a plus 2, plus 2, plus 2. So setting up our ratios, our first ratio going across is 55 over 2. Our second ratio was 60 over 2. And our third ratio is 50 over 2. Well, obviously these are not equal because that numerator changes and the denominator doesn't. So this is not a linear relationship. But we can still interpret the rate of change in the context of the table. So we're going to label our change in y and our change in x. So change in y was miles, and change in X was gallons. So what this means was, in this context, we are looking at miles per gallon, or MPG. I know this video is getting a little long, but I've got one more example. I'm going to keep the same topics linked together in one video. So one more time, looking at that change in Y and the change in X, we've got plus 5, plus 6, and plus 2. My change in X is plus 1, plus 1, plus 1. So you can probably figure out already whether or not our relationship is linear, but let's go ahead and set up our rate of change just for practice. So we have 5 over 1 for our first rate of change. Second rate of change is 6 over 1. And our third rate of change is 2 over 1. Sorry about the bell, I wasn't paying attention to the time. These ratios are not constant, so we do not have a linear function. And finally, we are still going to interpret our rate of change. So looking at labeling, we have change in Y over change in X would be change in cars over change in hours. So what our rate of change means is that in the first hour, they washed 5 cars. In the second hour, they washed 6. And in the third hour, they washed 2. So it is cars washed per hour.